Hello, I am Mr. Walid and I will explain how to find the distance using only a protractor. So I have already made some adjustment to the protractor. I have put a weight from the center of the protractor going down, and I have put something only to like a crosshair, something to look at the object. I want to find its distance. So to find the distance, you have to look straight through the this tube, and once you see the object, you will just see how much acute angle, how much the degree is it on. So for example, you are looking at the object and you have looked down and you saw that the weight is pointing at an acute angle 40 degree, for example. Okay, so this angle is vertical angle that you will be using to find how far is that object. So you have to look at the object. It doesn't matter where is the object. The object can be very far from you, like you are on the top of a mountain and you are spotting a car on the ground far from the mountain. So all you need to do to find how far that car is to look through the hole here and spot the car. And once you spot the car, you look at the angle. You just move, you don't move your hand, you move your head to see the angle that the weight makes with the vertical line. So it has to be acute angle. Okay. You also need another information to find how far the object is. You need to know the height that you are at when you are measuring this angle. So you need to know the height. So if you are on the top of a tower, for example, that tower is, for example, 100 meter long. It doesn't matter how much. You add this to your height if you are standing and measuring. So suppose your height, for example, is 1.5 meter, 1.5 plus 100. So it's going to be 100 and 1.5. So you have to find the total height where you are measuring this angle from. Okay, so you need the height and you need the angle. After that, you will do some trigonometry work to find the distance, the horizontal distance, or how far it is from the spotter. Or you can find how far the object is from the base of the building or the base of that height. So you can find any distance, tilting distance or horizontal distance. I will show you in writing. So, but in my writing that I will do now, I will consider that the angle is 40 degree. I spotted something from, I will do the question like I am on the top of a guard tower and I'm spotting an intruder. Okay, and that intruder appeared to be at vertical angle 40 degree. All right, and I know the height of the tower, for example, let's say not 100, because 100, I think 100 meter is too much. So let's say 30 meter is not bad. So 30 meter and my height 1.5 meter, for example. So 30 plus 1.5 will be 31.5 meter high. So see you in a second. Hello, I made already the question in writing. So it is an application in trigonometry. Okay, so it's basic trigonometry actually, but it is something we use in real life. We can use in real life. So I will read the question out loud, an intruder was spotted from the top of a tower at height 31.5 meter and with a 40-degree angle between the vertical and the tilting line. Okay, so this is the angle I was talking to you about that I measured by this protractor. So want to find how far is the intruder from the guard and also from the tower base. Okay, so in trigonometry, it's always advised that you make a little drawing to express the question, represent the question by drawing. So the vertical line will be for the tower. So I will draw. So that's a tower. So I can call it AB. That's the tower. Okay, I said when I was explaining this before I start here, I said I have to add all the height that is from the bottom until the spot where we are using the protractor, when we are spotter, from the spotter to, so of course the spotter will, the height of the spotter himself has to be added. Okay, so I said if the height of the spotter is like 1.5 meter and the whole tower is 30 meter, so the whole vertical line will be 30 plus 1.5 will be 31.5. Okay, anyway, the whole height here is 31. The whole height is the height, the vertical height, the height of the tower and the spotter together is 31.5 meter. Okay, so this is the vertical line. Okay, the car of course will be on the ground, so the ground will be a horizontal line from the bottom of the tower. So we draw a horizontal line. Okay, and the car will be here, C. Okay, so the spotter spotted with an angle 40 degree with the vertical, not with the horizontal, because it's different. If you say spotted with the horizontal, so it is called descending. Yes, we are angle of depression. So if you are looking down, angle of depression, there is angle of elevation and angle of depression is different than what I did. The depression and the elevation angles are between the horizontal line and the tilting line. Okay, so if I said angle of depression 40 degree, it will be between the tilting line and the horizontal. It will not be, but my work that I did is an angle between the vertical, because the weight was going down, so it will be between the vertical and the tilting line. So the 40 degree will be between the vertical and the tilting line. So it will be on angle ABC here. This is the angle that I measured by the protractor between the vertical, because the weight was going down, and the tilting line where I was looking at the object. Okay, it is something different than the angle of depression angle. If I looked down depression, with depression it will be the 40 degree will be out here, and the 40 degree, if it is out here, it will be alternate angle with this C. So the 40 degree here will be also 40 degree here. So it's something else I didn't write here. Okay, so my question, how far is that car from the guard? So we want to line CB. And also how far is the car from the base of the tower? We want to also line CA. Okay, so in order to solve it quickly, we have to see where is the right angle. The right angle, of course, will be between the vertical and the horizontal line. So here is the right angle, angle A. Okay, so this is a right angle triangle, and the hypotenuse is line CB. So this is a hypotenuse. Okay, so focus on the angle that you have. Inside that triangle, we have angle ABC, which is angle B. Okay, so the opposite to this angle, we will call it opposite. So this is the opposite. The line opposite to the angle, we call it opposite. Okay, so we know the hypotenuse and we know where is the opposite. Okay, what will be the third line called? It will be called adjacent. Okay, so the opposite is the line facing the acute angle. The hypotenuse is the line facing the right angle. But the other third line is called just adjacent because it's actually next to the angle, the acute angle. It's not hypotenuse, but it is next to the acute angle. So we call this line adjacent. Okay. So you have to decide which line you want to find first, because we have here two lines missing. The opposite is missing and the hypotenuse is missing. According to our question, the required from you is the distance from the guard to the car. So we want to the hypotenuse first. So we're missing the hypotenuse. Want CB first. Okay, so we're missing the hypotenuse. And so if you are missing the hypotenuse, to find it, you have to use what you know. What we know here is adjacent. So we have the adjacent and we are missing the hypotenuse. So we have to ignore the opposite for now. So we have the adjacent and we are missing the hypotenuse. So there are trigonometry rules you should know. Sine and cosine and tan. Sine is opposite over adjacent. Cosine is adjacent. Sorry, so I will write the three rules. Sine theta opposite. Sorry, sine theta is opposite over hypotenuse. Cosine theta equal adjacent over hypotenuse. Tan theta equal opposite over adjacent. Okay, so we have the three rules now. I made mistake in the beginning. I said sine theta something else. It is sine theta equal opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tan theta equal opposite over adjacent. Okay, so you have to use one of these three rules. Only one of them. Okay, it depends on what you want and what you have. Don't look at what you don't need. What you want and what you have. Okay, so we want now the hypotenuse. We want CB, the distance between the car and the guard. So this is what we want. And what we have is this line, AB. So what we want and what we have only we look at. So this is what we have. So we look at these two only. So we have two words, adjacent and hypotenuse. So this is appearing in cosine rule, adjacent and hypotenuse. So this is the rule we use, cosine theta, but we will not write theta, we will write B, because the acute angle here is angle B. So I write cosine B. Why don't I use the sine rule? Because for now I don't want the opposite, and I don't even have the hypotenuse. So I don't use the tan rule, because I don't want the opposite now, and I don't. Yes, I have the adjacent, yes, but I don't want the opposite. I want the hypotenuse, and I have the adjacent. So the cosine is my rule. So cosine B, instead of writing theta, I write B. Cosine B, cosine B, and get the acute angle B equal what? Adjacent over hypotenuse. Okay, so what is the I replace everything by its value. If I have angle B, I write its value. If I have the adjacent, I write its value. If I have the hypotenuse, I write its value. If I don't have something, I write its name. X, Y, L, M, A, B, A, C. So cosine will be written as this for now. Cosine. Okay, do I know angle B? How much it is or not? It is 40 degrees. So I write cosine 40 degrees. Okay, equal. Okay, adjacent on the top, I make fraction line. So do I know the adjacent? How much it is? I know it is how much? 31.5 degrees centimeter. So I write on the top 31.5 meter. Okay, the hypotenuse, I don't know. So I write its name, CB, okay, which is the distance. So this is CB. Okay, to find CB, we will do some cross multiplication. So it is, to do cross multiplication, you need two equal fractions. So I have here no fraction, so I will make fraction line over 1. If you have no fraction, you can make over 1 directly. Okay, so I write what I am finding. So I am finding CB, so I hide CB. Where are the two numbers making a cross? Cross is like the multiplication sign, like that. Let me do so, like this, cross, like two cards holding two swords. So the two numbers making cross here are the 31.5 and 1. So these are my two numbers. I time them together, multiply them, and divide by the third. So before I do that, I write CB equal, because I have to write what I'm finding. So I'm finding CB, so I write CB equal. CB equal, I make division line or fraction line, what times what divided by what? The two numbers making cross times each other divided by the third, which is cosine 40. So 1 times, it will be 1 times 31.5 divided by cosine 40 degrees. So which is approximately, of course here will be, so 1 times 31.5 divided by cosine 40. Okay, so approximately 41.1 meter. So this is 41.1 meter. So the distance between the guard, so this is a distance between the guard from C to B, from the guard to the car. So we say the distance between the guard and the car. So this is the distance between the car and the guard. All right. And what is the next? What is the next required from us? The next required from us is the distance between the car and the base of the tower. So we want CA. CA, same way we see what is it that we want now. It's CA, so this is CA we want. We look at what we want and what we know. Okay, so you say here we know we know the hypotenuse already. It's better to use what is given in the question, not what you found, because maybe what you found is wrong. So you should use what is given and ready for you. So we know the adjacent and we want the opposite. We want the opposite, we know the adjacent. Opposite, adjacent, which rule has opposite and adjacent on it? The tan rule. Opposite and adjacent, so we write the tan rule. But instead of C theta, we write B. So we write tan B. It has op because it has the opposite and the adjacent. We want the opposite and we have the adjacent. So this is our rule. So tan B equal opposite, which we want, over adjacent, which we already know. And same steps again, we write the angle B, how much it is. So I write tan as it is. This tan will not change, but this angle B, its value will be written if we know. So it's 40 degrees equal opposite. The opposite is unknown for me, so I write its name. Its name is CA, and the adjacent is given for me 31.5. Okay, so CA will be what times what divided by what this time. Okay, I make fraction line. to do over 1. So the two numbers making cross are these two numbers. Okay, so notice this is not 40, this is 1040. This all is one number. 1040 times 31.5, or 31.5 times 1040 divided by 1. So that's CA. Do cross multiplication. Two numbers making cross times each other divided by the third. So I will write here CA equals 31.5 times 1040. 31.5 times 1040 degrees. And notice I wrote the number first before the 10, because I don't want to say 1040 times 31. I don't want two numbers to be written next to each other and you get confused, because this 1040 is one thing together, and this 40 is not by itself. It is an angle that is stuck with the 10. So I just prefer to, if you have a number multiplied by a trigonometric ratio, write the number before the trigonometric ratio, because the trigonometric ratio will have an angle inside it. You don't want to mix the angle with the number. So 31.5 times 1040 divided by the third number, which is divided by 1. So CA approximately will equal, so 31.5 times 1040 divided by 1, of course, will be the same thing. So it's 26.4, approximately 26.4 meters. So this is the distance. CA is the distance between the car and the tower base. So that's the distance between the car and the base, the tower base, the base of the tower. Okay, and that's how you find the distance using protractor. Thank you for listening. I hope this was useful for you. Goodbye.